Welcome everyone. Let's learn to solve the two-sum coding interview question in today's video. In this two-sum problem, we have been given an array of integers called nums and another integer called target, and we need to find two numbers which add up to this target, and we need to return the indices of these two numbers in this array. Let's look at an example here. So we have this input array nums which contains these values, and the target is 9. So we need to find two numbers which add up to 9. And if you look at this array here, we can see that the number 2 and the number 7 add up to 9. And we need to return the index values of these numbers. So the index of 2 is 0, the index of 7 is 1, and that is what we are being asked to return. Okay, let's look at this example which has these numbers in the nums array, and the target we have been given is 11. As a brute force approach, let's say we have a variable I which points to index 0, and the number there is nums of 0 which is 1. Okay, so what number do we need to add to this one to get to the 11? And that is 11 minus 1, which is 10. Now our next task is to scan the remaining array and search for this number 10. So we can use another loop, and let's say we use the variable j going from index I plus 1 till n minus 1. And we will iterate through this part of the array in red, and at every index we will see if we have the number 10 in this array. In this case, we'll see that nums of 1 is 4 is not equals 10. So we will go to the next index and we'll see again that it's not 10, it's 2. The next index we see that the number is 8. We will move on to the next index, which is the last index here, and again we haven't found the value 10. Okay, so what we have to do now is ignore this number 1 and increment this I to go to the next index. So now I is 1, and we need to scan the remaining array again for the number which when added to 4 gives us 11. And what number is that? So in this case it is 11 minus 4 equal to 7. We will iterate this array again. So going from index 2, so j is at index 2, and when we do that we'll find that at index 4 the number 7 does exist, and our return value in that case will be an int array containing the index values in I and j. So in this brute force approach, we iterated this array going from I equal to 0 to n minus 1, right? So I goes from here till all the way here, and then for every value of I, we took the array starting at index I plus 1 and scanned it completely till we found the number which when added to the element pointed by 1 gave us the target 11. And inside of this loop we did another loop where we have j equal to I plus 1 to n minus 1. Right? Roughly the complexity of this approach would be of n square because of these two loops here. In the brute force approach, we saw that for a given element at index I, we were iterating over the rest of the array to find a number at index j such that both these numbers when added up gave us the target number 11. Instead of iterating the array in search of this number which we found at index j, what if we could keep track of all the numbers that we have seen so far? So let's say we are at index 1 and the element is 4, right? The number that we need to add up to 11 is 7. We're going to use a data structure, okay? And we're going to ask the data structure if we have seen this number 7 already, right? So as we iterate through this array, we will store the numbers that we have seen in that data structure. Okay, so that will be the idea. I can see here that the number 7 hasn't been seen here. Okay, we will move on to the next number, which is 2. Now here we need the number 9, and we can see that we haven't seen this number 9 here. It's 8, and again we haven't seen the number 3 because 8 plus 3 is the next element, and that is the last element here, which is number 7. And we're going to ask this structure or the cache, have we seen the number 4 at all so far? And it will have seen the number 4 because we're tracking it, right? And it's going to say, yes, I have seen the number 4. And then what we're going to do is we're going to also ask it, can you give me the index of the number 4 which you had seen already? So we need a structure which not only keeps track of the numbers that we have iterated, but also their indices, so that when we find that number, we can also retrieve its index value. And the best structure for doing this kind of retrieval is the Hashmap or dictionary. The basic idea of the Hashmap is that it contains key and a value, okay, or it's basically like a collection of key value pairs, right? And we store a key in it and we store a value for that key. So let's say the key is the number 4 here, okay, and let's say the value is the index, which is 1. Then when we need to retrieve a number, we're going to simply ask, have you seen this number? And if it's existing in that hash map, it will say yes. If not, it will say no. And if it says yes, then we're going to ask it, can you give me the value of this number? And using that value, which is actually the index of this number 4, we can then say we have found a pair at index 1 and index I, and that is how we will calculate the result. So let's go through this array and apply this hash map idea. Okay, so we have got our hash map here. Okay, we can call it num to index, which contains the key as the nums of I. So we'll store the number in the key, and I will be the index of that number, will be the value in this hash map. Okay, so that's why I'm calling it num index map. The first number in this array is number 1 at index 0, and the number that we need to add to this number to get 11 is 10. We're going to ask the hash map if it contains this number 10, and we can see that the hash map doesn't contain this number 10. But what if we find the number 10 somewhere later down in the array? Then we would need to know if the number 1 existed in this array and what was its index at that point in time. So for that reason, we will store the number 1 in this hash map and its index 0. Okay, and we'll move on to the next index. At the next index, we have the number 4, and 11 minus 4 equal to 7. And we're going to ask the hash map if it has seen the number 7 already. And in this case, the answer is no, because we haven't seen the number 7 in the previous part of this array, right? So we'll store this number 4 in the hash map like so, and also its index 1 like so. And in the future, if we do find the number 7, then at that point, we would need to know if we have seen the number 4, because 7 plus 4 is 11, and that's why we stored this number 4 now in the hash map. At the next index, we have number 2. We need a number 9 which doesn't exist in the hash map, so we will store the number 2 and its index 2 in the hash map. And the next index is 3, okay, and the number there is 8. So 11 minus 8 equal to 3. We're going to ask the hash map if it has seen this number 3 before. We haven't seen this number 3 before. As you can see, it's 1, 4 and 2. We're simply going to store 8 in this hash map and its index 3. Finally, we move on to the last element in this array, which is number 7. So now 11 minus 7 equals 4. We will ask the hash map if we have seen this number 4 in the past in this array. And the answer to that question will be yes, because here we can see the number 4 already exists in this hash map. So that's good, because now we have found two numbers which add up to this number 11. But we need to return the index of it, which is what the value holds here. So we will ask the hash map, can you give me the index of this number 4? And it will return us this number 1. We will take this number 1 and the value of I, which is 4, and simply return the integer array containing the number 1 and the number 4, which is pointed by I. So this is how, using hash map, we can solve this problem, and the complexity of this approach will be O of n, because we are simply doing a single pass of this array. I hope this made sense. Now let's implement the code for this approach. So let's first define the hash map, num index map, in which we will store the elements and their index values which we have seen so far. So the hash map has key of type integer and the value of type integer. I'm calling it num index map. The key in this hash map will be the nums of I, and the value will be the index of every element that we have seen so far. I will now iterate over through the input array. Now if you remember, for every element that we are iterating over, we are trying to find what value we need so that the current element and that number both add up to the target. So to do that, I'm going to subtract the current element from the target, and that will be my required value. Now I'm going to ask the hash map if it has seen this value already. In Java, the contains key is a method on the map which tells me if a key exists in it, and if it does exist, then we're going to retrieve the value which is going to be the index of the number which we had seen in the past, and combine that with the index I of the current number and return that as an array of 2 elements. And now what if the required number doesn't exist in the hash map? As we just saw, in this case we will store the current number and its index into the hash map. Now we have been guaranteed that there is always going to be exactly one solution. So we are guaranteed that we will always find it and we will return it here. But we have to return something, so otherwise we're going to get a compiler error. So in this case, when we don't have any solution, we can either return a null or throw an exception. I'm just going to return a null in this case. Now let's give this a run. Okay, that's looking good. Let's try the test case we used in our example, and here you can see that the output is 1, 4. At index 1 we have the number 4, at index 4 we have the number 7, and this is the right answer. So I hope you found this video useful. If you have any questions, please do write them in the comment section on YouTube, and please do remember to subscribe and like. Thank you. Bye.